In this lecture, we'll be continuing the topic of thermal properties of matter, but broadening the scope to include phase transformations. That is, what happens to the temperature and heat flow when a substance undergoes a phase transformation. We'll be focusing on the transformations from solid to the liquid or liquid to gas, but it's also important to know that you can have solid-solid transformations, where a solid may change from one crystal structure to another as a result of the application of pressure or temperature. A somewhat famous solid-solid transformation is that of tin. White or metallic tin transforms from one crystal structure, called grey tin, at about 13 degrees Celsius. Grey tin has very different mechanical properties to the original metallic tin structure, and is actually a lot more like chalk, powdery and brittle. Not at all the type of material you would want to make buttons for your jacket from. Look up Napoleon's failure to invade Russia if you're interested. Anyway, back to the topic. At the end of this current section, you should be able to answer the following questions. Why doesn't adding heat to boiling water make your noodles cook faster? Why is a steam burn so dangerous? And how efficient is evaporation of water, sweat as a cooling process? So let's look at the concept of latent heat. Latent heat, L, is the energy per unit mass associated with inducing a change of phase. What does this mean? Well, this is a process whereby heat is added to a system, but no change in the temperature of the system is observed. From what we've seen so far, this could seem counterintuitive. You might remember that heat equals the specific heat mass delta T. So heat is proportional to the change in temperature delta T. That is, if you add heat, you should see a temperature change. So let's take the example of heating a saucepan of water again. As we add heat to the water, we see that the temperature of the water increases from room temperature to around 100 degrees C. But at this point, something interesting happens. We continue to add heat to the saucepan, but we are not getting any resultant increase in temperature. What's going on? Is physics broken? No. Of course you know what's going on. We have reached the boiling point of water, and you cannot raise the temperature of the water above the boiling point, which at sea level is of course around 100 degrees C. And the heat, which you know you can think of as energy, being pushed into the system, is being used to transform the liquid water into vapor, steam. The amount of heat we need to drive such a phase transformation is called the latent heat. We can write that heat Q equals mass M times the latent heat L. The value of L is different for each transformation. The latent heat of fusion is for a solid liquid transformation. The latent heat for vaporization is for a solid gas transformation. The values for water are the latent heat of fusion equals 333 by 10 to the 3 joules per kilogram, and the latent heat of vaporization equals 2256 by 10 to the 3 joules per kilogram. This means if we have 1 kilogram of ice at 0 degrees C, we need 333,000 joules to melt it. And if we have 1 kilogram of water at 100 degrees C, we need a whopping 2,256,000 joules to turn it into steam. To put these numbers in context, it takes about 1 joule to lift a small apple 1 meter in the air. We're talking about millions of joules to transform a kilogram of water into steam. Thus, we're talking about a lot of energy. But what's going on from a physical point of view? If we want to understand the physical reason for this observation, we must go back to our microscopic model of the structure of matter and consider the substance on a molecular level. When a substance is in a solid form, there are bonds between the atoms holding them roughly in place. They can vibrate, and this kinetic energy is related to their temperature. So when a phase transformation occurs, say in the case of ice melting, we need to add energy to break these bonds. In this case, we are adding energy in terms of heat, but we are not seeing an effect in terms of temperature, and so this is called a latent heat. This is also true of the transformation between liquids and gases. We need to add energy to break the bonds between the water molecules. The temperature of the material is not changing as the kinetic energy is not changing. Instead, work is being done against the forces holding together the bonds. I'll just add the numbers for water. Note that these are in kilojoules per kilogram because they're such big numbers. So latent heat is the heat flow without a temperature change. We are instead, of course, inducing a phase transformation. Energy is given back to the system, in a sense, when we go back the other way. When liquid water freezes, for instance, a lot of energy, in fact 333 kilojoules per kilogram, is released. But practically speaking, if we are driving the process, i.e. we are melting ice on our windshield or cooling water to make ice for our drinks, we need to add or subtract a large amount of energy. Latent heats are the same in this direction. To go from gas to a liquid state is 2,256 kilojoules per kilogram, and for the liquid to solid transformation, 333 kilojoules per kilogram.